Good day. I am Engineer Raymark Endaos, a graduate student for the ES213, the numerical methods for engineers. And I am tasked to report about the roots of nonlinear equation, Brent's method, and multiple roots. Brent's method, also known as Brent's minimization algorithm, is a hybrid algorithm for finding roots of continuous functions. It combines the principles of bracketing methods, such as bisection, with open methods such as secant and inverse quadratic interpolation to provide a robust and efficient root finding technique. So Brent's method has four s- uh, four stages, or four types, four stages of determining the roots. First is the bracketing phase, iterative refinement, the convergence criteria, and guaranteed convergence. So first is the bracketing phase. Brent method starts with an interval bracketing the root where the function chances sign. This bracketing phase is usually done using methods like bisection or by selecting initial points such that the function evaluates two opposite sides. The next is iterative refinement. Once the bracketing phase is complete, Brent's method iteratively refined the root approximation by switching between bisection, secant, and inverse quadratic interpolation steps. It dynamically selects the method that is likely to provide the most accurate approximation in each iteration. Convergence criteria. The algorithm continues iterating until the root is found within a specified tolerance or until a maximum number of iterations is reached. It ensures that the estimated error decreases with each iteration, providing a reliable approximation of the root. Guaranteed convergence. Brent's method guarantees convergence under reasonable assumptions, even for functions with irregular behavior or pathological cases. It combines the stability of bracketing methods with the efficiency of open methods to ensure a reliable root finding across a wide range of functions. So Brent's method, so Brent's method atong summary. So na siya combining strength is motivated by the desire to combine the strength of various root finding algorithms. Traditional methods like the bisection method guarantee convergence but can be slow. Open methods like the second method are faster but lack robustness, particularly when encountering regions where the function is nearly flat. By combining this method, Brent's method aims to achieve both fast convergence and robustness over a wide range of functions. So, handling different behaviors. Different functions may exhibit varying behaviors such as sharp peaks, flat regions, or discontinuities. Brent's method dynamically adapts its strategy based on the behavior of the function during the iteration process. It switches between bisection, secant, and inverse quadratic interpolation methods as needed, effectively navigating to different types of functions. Guaranteed convergence. Brent's method is designed to ensure convergence even in the presence of irregularities or pathological cases. It employs strategies like bisection to guarantee convergence at each step, thereby providing a fail-safe mechanism to prevent divergence. So, balance between efficiency and reliability. Brent's method strikes a balance between efficiency and reliability. While it aims for fast convergence, it prioritizes stability and robustness to ensure that the algorithm reliably finds the root without getting stuck or diverging. So, ang Brent method po dahil kay widely applicable across various fields of science, engineering, and mathematics. It can efficiently handle a broad range of functions encountered in practice, making it a versatile tool for numerical computation. So let us proceed to the mathematical background of the Brent's method. Brent's method involves understanding the principles behind root finding algorithms and how Brent's method combines different techniques to efficiently locate roots of function. Wouldn't it be nice to have a hybrid approach that combined the reliability of bracketing? So, rela- gi una ang so pag-combine kuha ni siya klase-klase na method. Ang una is reliability sa bracketing, speed sa open methods, dayon root location method is a clever algorithm that does that just that by applying a speedy open method wherever possible, but reverting to a reliable bracketing method if necessary. This approach was developed by Richard Brent in 1973 based on an earlier algorithm of Theodorus Decker. So, gipa-improve na din ni Richard Brent ang idea ni Theodorus Decker sa gikan itong 1969. So, example, find a root of the function of x is equals to x cubed minus 2x minus 5. So, ang igamit na ko ani is MATLAB na yun naka-create ta o nakapangita ta og code nga input sa MATLAB nga para ma-apply na to ang Brent's method sa MATLAB sa pagkuha ato nga example. So mo ni siya ang kuan gigamit nako na code nga gigamit dito sa MATLAB. Mo ni ang sumpay. So medyo taas-taas siya, dagan siya mga kuan kay kuan man naaman nakasulod man diri tong ah tong mga method, um, open method, quadratic interpolation, second method para ito tong giingon ganyan para paspas o reliable ang pag-find sa root sa function. So, ano siya? Sumpay niya na kuan. Kita na to diri na napod ang bisection method. So, pagkahuman og input ani na pagkahuman og input ani na code sa MATLAB, so pwede na din ta makaproceed sa pagkuha og root. So, ang code na po dayon na atong i-insert sa MATLAB is para makuha ang function of x is equals to x cubed minus 2x minus 5 is kanina po din siya na code. So, kita na to define the function. Initial interval a equals to 1, b equals to 3. Naput siya tolerance and maximum number of iterations. One din in katong find the root using Brent's method katong atong gi-input kaniha nga code. Mo din na yang gamiton. So display the result. So ang yatag niya sa tuwa is approximate root 2.0946. Mo na siya. So pagka-explain ato na kuan ang code is start ta sa initialization. The function initializes the values of function of a and function of b at the endpoints of the interval ab. Nanabutan ng bracket. It also checks if the sign of function of a and function of b are opposite, which is a necessary condition for the existence of a root within the interval. Main loop. The main loop iteratively applies, iterate niya, pag-iterate niya, gigamitan niya o Brent's method to refine the approximation of the root. It alternates between inverse quadratic interpolation, second method, and bisection method based on certain condition. So, gigamitan niya o inverse quadratic interpolation, second method, and bisection method based on certain conditions. Root update. At each iteration, the function updates the values of function of a and function of b, narrow down the interval containing the root. It also updates the function values of f of a and f of b accordingly. So, convergence criterion. The loop terminates, tanggalon niya when the absolute difference between f of a and f of b becomes smaller than the specified tolerance. Tol mo na siya kaniya ang nasa code. Tol. Indicating convergence to an approximate root. So, ang output dayon is the function returns the approximation of the root. This implementation should work well for finding roots of function within specified intervals. You can call this function with your desired function of x initial interval ab, tolerance, and maximum number of iteration max iter. Ano siyang code sa maximum number of iteration pila. Adri is 100. To find the approximate root. So, example mo ni siya nga itong example. Mo din ni siya ang code sa Brent's method which is na-adito ang inverse quadratic interpolation, second method, o sa isa, bisection method. So, kani siya ang atong example, muna din ni siya ang kabali second na code para pagkuas ng example. Dayon, butan na rin na state na find the root using Brent's method. Tekanin ta niya ang answer. So, next sa Brent method is 2.9 multiple roots. Solving nonlinear equations is crucial in various fields such as engineering, physics, economics, and many others. However, some equations may possess multiple roots, making their solution more challenging. Understanding how to find and analyze these multiple roots is essential for accurate modeling and prediction in various applications. So, multiple roots na po. Mathematical background. Nonlinear equations are represented as x is equal to 0, where f of x is a nonlinear function of x. When dealing with the multiple roots, the function fx may intersect the x-axis at multiple points. So, the function of x daw, kaya pwede ra daw mag-intersect sa x-axis at multiple points. Ano siya, multiple roots. Such equations can be found using numerical methods like Newton-Raphson, second method, bisection method, and among others. So, ang method daw, isa sa mga method sa pagkuha sa multiple roots is kining ingon nila na Newton-Raphson method. This iterative technique uses an initial guess approximate the roots of a nonlinear equation. The formula for the next approximation is x sub n plus 1 equals to x sub n minus function of x sub n over f prime of x sub n, where f prime of x is the derivative of function of x. Second is the second method, similar to the Newton-Raphson method, but doesn't require the derivative of fx. It approximates the derivative using finite differences. So f prime of x sub n equals to function of x sub n minus 1 minus f x sub n over x sub n minus 1 minus x sub n. The third one is bisection method. This method works by repeatedly dividing the interval in which the root lies into two subintervals and selecting the one where the function changes sign. So, dito sa example, solve a function of x is equals to x cubed minus x squared plus 11x minus 6 equals to 0 using the Newton-Raphson method. So, apply the initial guess, x sub 0 is 1. Iterate using x sub n plus 1 equals x sub n minus, amat siya ganiya. Ini, x sub n plus 1, Raphson method equals to x sub n minus f of xn over the derivative of f of x. Muna siyang f prime of x until convergence. No, number 1 ta. O kani siya, example, muna siyang akong gigamit nga code dito sa MATLAB. So, sa pinakataas nga part, define the function. Pagkahuman, kinanglan man nato itong derivative sa function. So, muna siya. Pagbutang tag tolerance, then kinanglan ta og initial guess. Basta Newton-Raphson method. So, x sub 0 is 1, x sub 1, x3. maximum number of iteration 100. So, mo din yung condition. Iterate to find roots. Compute next approximation using modified Newton-Raphson formula. Tapos, giingon siya diri na i-iterate taman mag-converge. So, nakabutang po diri check for convergence. Update variables for next iteration. So, wala siya. Muli na niya itong nakuha na ang first root niya is 1, second root is 3. Di siya para ganiya sa Brent's method no na magbutag kuandaan code then ingon lang din nato na use Brent method. So kani siya isa lang siya ka code. Gibutan lang din dito ang mayang mga condition. So number 2. So f of x kaya na pod number 2 ha. F of x is equals to e x minus x squared equals 0 using the second method na code. So kaning second method apod siya mga initial guess. So wala na ko na x sub 0 x sub 1. 0 ug 1. Iterate using kaya na po siya sa second method. Formula. So sa sample number 2, exponential. Balhin ang ganoon. So medyo taas-taas siya nga code kay second method akong gibutang direto loka guesses. Then ang gibutang sa sample nako is duha lang pero gitry na kog tulo. So maghapon to first define the function, set initial guess 1 negative 1 2 tolerance iteration. So monetize ni siya kay iterate using the second method for the first root. Dayon ang kay na may kuan na po'y second method for the second root. Iterate na po siya. Dayon third root. So apo din siya sumpay. Yung pinakalas sa code. Check if solutions converge or max iterations reach. So, sa mo ni akong nakuha. Negative 0.70347 first second root pariharan negative 0.7. So, wala to siya ang akong i-share sa inyo about Brent's method and finding multiple roots using Newton-Raphson method o second method and using the program MATLAB. Input the codes and magkuhan ka og mga kuan niya. Ito ba niya? Arguments. Oh, arguments ba na? Conditions. So, thank you and God bless everyone.